Arigato. Thank you. I'm here today to talk about upcoming features in Lustre. And as you can see, my hair's much shorter, more business-like. But so we'll talk about the near future releases, and I prefer to work and only discuss the features that we're actually working on. I try not to talk about things that are too far in the future that are not necessarily going to be implemented in a timely manner. So as you can see, there's a number of features that are already in the upcoming 2.13 release, and we hope that that will be out within a few weeks. And there's also a number of interesting features that are under development for the 2.14 release, and we've already started on some of the features that are going into 2.15 as well. One of the very interesting features that is in the 2.13 release is the persistent client cache, and that is allowing local storage on the client to accelerate some workloads, such as machine learning that have very large input data sets that they read frequently. It allows using an NVMe device or other local storage. It's also been tested with NVRAM that's shown very good performance. And unlike, it uses the Lustre HSM feature, so hierarchical storage. And normally HSM is used with tape devices, but what we've done here is use HSM to store files in and out of the storage that's local to the client. And so if the client is accessing that data locally, it can do it very quickly. It bypasses all of Lustre and can even use local persistent memory interfaces like DACs. And then if another client tries to access the file that was written locally, it uses the HSM mechanism and it pulls it out of the local memory or persistent memory or NVMe device and pulls it back into the shared storage. And so that's transparent to the applications, but can give very good performance when the files are located in NVMe. Getting the files into NVMe is done through job directives or manual requests from the application, and we're also looking at a policy that can automatically bring files into the local storage based on file names or other policies such as the user ID. There's also been in the 2.13 release a number of improvements to D&E, which is the ability to use multiple MDT devices in a single file system. And by existing users of D&E today have had good experience with improved performance from multiple MDTs and multiple MDS nodes, but it's a bit more difficult to use than we would like. And so we've been working on making D&E easier to use. And the most important one that's gone into 2.12 and 2.13 is the ability to automatically select an MDT when the file system is imbalanced. And so if one MDT is nearly full, 85%, and another MDT is only 15 or 20% used, then it will allow you to put new directories on the less full MDT. And in 2.12, you had to explicitly run a command to create each directory. In 2.13, it's possible to set a policy on the the parent directory, and then the applications can just use the regular make dir operation, and so then it will select the best MDT to locate the file on. In 2.14, this will become more automatic, so that instead of having to select a remote MDT or having to stripe a directory over multiple MDTs explicitly, it will dynamically restripe a directory as it's growing in size. And so that will allow applications to use all of the MDTs for improved performance and to do better space balancing automatically. And another important improvement that's in the 2.13 release is improved metadata performance when you're using striped directories. So that was provided by a developer at Uber, and they noticed the performance difference between D&E and non-D&E directories, and so this this improvement has shown good benefits. Another new feature in Lustre 2.11 was the data on MDT, and this allows storing small files directly on the metadata server, which is typically Flash and has a very high storage performance. And instead of storing the files, small files on OSTs, which are disk and RAID 6. And so again, after the initial development of the feature in 2.11 and 2.12, we've been working to improve the performance and make it easier to use. One of the new enhancements is the ability to mirror a file using the Filelevel replication feature, and to mirror the data from the MDT component onto an OST. And so if the file is small, it would reside on the MDT, but essentially a backup copy would be on the OST. And as the file grows larger, the progressive file layout feature will allow the rest of the file data to go on the OST. This also allows you to do migration of small files either onto an MDT or migrating the MDT component off of the MDT onto entirely be on the OST, so that you're able to use the space on the MDT more effectively. You don't have to store the first part of a very large file there. So what's been seen, and I think Ihara talked about this earlier, is that data on MDT has shown good improvement to performance, and we're continuing to work on that. In 2.14, there will be a feature to allow you to dynamically select the data on MDT component size, so that if you have lots of free space on the MDT compared to the number of inodes, it might give you more, larger files could be stored on the MDT, and if the space is starting to run out, it may shrink the component that's stored on the MDT so that you don't run out of space. And there's also other performance improvements. One of the interesting ones that some people have asked about is allowing a MDT only file system. If you have a workload that is using only small files, right now that's not very efficient in Lustre, but with data on MDT, you could potentially have a file system that's only storing small files on the MDTs. As well, another new feature in Lustre, relatively new, the Elnett MultiRail, that was discussed earlier as well, and we're improving the functionality of that in 2.13. The multi-rail routing functionality was added, and so in addition to handling direct connections between clients and OSTs and MDTs, if there's a Elnett router in between, so if you have a bridged network, maybe InfiniBand to Ethernet or OPA to InfiniBand, the Elnett routers can have different numbers of interfaces on either side, and it will effectively load balance and handle failures across those interfaces. For the next release, 2.14, the next Elnett feature that's going to be developed is called user-defined selection policy, and that allows the administrator to configure on large NUMA systems which interface inside the system is the most efficient for a given message, or if you have two different kinds of networks connected to a single node, let's say in high-speed InfiniBand interface and a slightly slower, 10 gigabit Ethernet or 100 gigabit Ethernet, you can specify a policy. Right now it round robins based on essentially performance balancing. So if your IB interface is 4 times as fast as your Ethernet interface, you would get 4-to-1 distribution of messages. But you may want to put all of your traffic on the InfiniBand because it's lower latency, and not put any traffic on the Ethernet unless there's a failure. And so you can specify different kinds of policies. And there's been a number of improvements for single client performance. Back in the old days of Lustre development, the performance of the system was almost entirely, the bottleneck was on the servers. And each individual client only had 1 or 2 cores and a relatively slow network. And so single client performance was never really a development goal. With newer systems, a single client may have 96 or 128 cores. If you have GPUs, they may have thousands of cores, 4 times InfiniBand interfaces, and so single client performance is becoming more important. As well, the change in workloads from large MPI applications that are distributed across lots of clients to more ensemble jobs, AI and machine learning that are running independently means that they can benefit more from improved performance of a single client. So we've done changes to improve single-threaded create. I mentioned that under the D&E slide, and so that gave us about 3 times improvement for single-threaded workloads on one client. We've improved the read-ahead so that nearly doubling the performance of read-ahead from a single client. Another interesting feature is called overstriping, where in the past you could only have 1 stripe of a file on each OST, and that was fine because individual OST performance was not very high. But with large disks and flash, the performance of individual OSTs may be quite large, and so for a client to get the most performance out of a single large OST, it's beneficial to put multiple stripes from a single file on there. And in the IO500, we saw very good improvement there. It gave us more IOPS in order to get more parallelism on the server file system as well, reducing lock contention and things like that. I said, the strided read and write has improved. We're going to continue that work to improve IO500 performance for 2.14. While on the one hand, optimizing for a benchmark is, not always good, but the IO500 benchmark is actually, I think, quite a good one because it not only has an easy component that shows you what the best the system can do is, it also has a hard component that shows you the worst that the file system can do, and it's a very difficult workload. And so if you can improve the hard part of the IO500 benchmark, you're likely going to improve the overall file system performance for applications as well, because very few applications get the hero result, and most of them are somewhere in between the good and the bad, and you try to make the 2 of them the same. As well, for some of the other features that I talked about, file level redundancy and HSM, things like that, it's useful to have clients mounted directly on the server. And so we're starting to do some optimizations to allow clients to mount directly on the server without causing problems in recovery or memory allocation. And so that's going to go into 2.14. We have a patch, it just didn't make it into 2.13. I won't go too much into this. I think Ihara covered a lot of this already about Flash performance, and we've done a bunch of work on the servers to improve the efficiency of the servers. I think we'll also need to do, in 2.14, we're going to continue, looking at how we can reduce overhead and make the I/O more efficient, because the less software that's in the way of the storage, the better that we can have the utilize the very fast NVMe storage. One of the interesting features that isn't directly related to the performance, the self-extending layouts, was developed by Cray, and it allows you to handle OSTs that are quite different in size, right? Typically the Flash OSTs are much smaller, but they're more likely to run out quickly, run out of space. And the self-extending layouts lets you have, the first part of a file. It's an extension of the progressive file layouts. It lets you have the first part of a file on Flash, and then the later part of the file is on spinning disk. And the innovation here is that the boundary between the Flash and the disk can be dynamic based on how much free space is on the Flash OSTs, right? So with the, up until 2.12, the PFL separation between, let's say, a Flash pool and a disk pool was a static boundary. And so we can improve that with the self-extending layouts. And that just makes it easier to use. As well, the backing file system, LDiskFS, has had a number of improvements. In terms of features, we're trying to reduce the effort that we take to maintain this and move it to newer kernels. So a number of the features were merged into the upstream kernel and upstream E2FS progs. There's still a few features that were developed specifically for Lustre, the Dear Data feature, for instance, that we're trying to get into the upstream kernel. But what's also interesting is that Google and other cloud storage vendors still use ext4 as their backing storage as well, and so they're continuing to work on new features. One of the existing ones that is quite interesting for Lustre is Big Alec, which should, in theory, make large OSTs more efficient. Inline data could help with very small files, that are a few hundred bytes or a kilobyte or something like that, to be more efficiently stored with data on MDT. Metadata checksums to ensure data or metadata integrity. File system encryption. I actually didn't list that here, but ext4 also got file system encryption, and data checksums is under development by Google as well. So file level redundancy is allowing Lustre to have multiple copies of the data on separate OSTs, which allows you to have a more robust system, either because of hardware failures, because of network failures. I mean, often people using Lustre as, everybody blames Lustre as having a problem because that's what applications see. They see the file system is not working. But there's a large stack of components underneath Lustre, the networking on the client and the server, software stacks and InfiniBand and things like that. And so if there's any problem, it's, easy for users to blame Lustre about that. But if we have redundancy across OSTs, we can avoid, showing application problems. if they can easily read, the data from a different OST. And so that feature was added in 2.11. We're making it easier to use, improve the command line interface. The next big feature or phase of the FLR development is erasure coding. So instead of doing full file mirroring, it will be possible to add striping, essentially a parity stripe or 2 or 3 onto an existing striped file. And so that will allow you to have, availability without, 2 or 3 times overhead compared to the mirroring. And we're using the Intel ISAL library so that it will be very efficient CPU instructions to compute the erasure code. And, you can have an arbitrary, number of failure domains depending on your configuration. You can have, 4 parity stripes if you want. Other improvements to integrate HSM into the Lustre layout so that instead of having HSM as a separate, a separate type of redundancy on a file, you can actually have it built into the Lustre layout so that right now we can only have one copy of a file in HSM. But with, FLR and HSM together, we could actually have 2 or 3 different copies. We could have copies in, different cloud regions or different cloud providers, even, one on S3 and one, on AWS and one in, Azure or something like that. And that gives us a lot of flexibility. And then we're also starting the design on a reflink feature, a Lustre level reflink, which allows you to have copy on write semantics for individual files. And that could potentially work to allow you to have file versioning on individual files, similar to what VAX VMS had. There's also a number of other improvements. I won't go into the details of each one. I mentioned overstriping. LFS find is got some improvements for performance. There's there's a whole separate presentation on Lustre, work that's being done to clean up the code so that it can go into the upstream kernel, and so that's continuing to be done by Oak Ridge and SUSE. More, there's a number of other interfaces, kernel interfaces, fallocate and statx, that we're going to implement support for in Lustre, which can help, applications to be more efficient. Another feature that Cray is working on is pool quotas. Again, this is going to help with Flash in particular, so that you can put a quota on the Flash OSTs and limit, users from consuming all of the space on the Flash, and allow to have multiple tiers without without malicious users, or users just don't know that they're doing this. Another major feature that we're working on is client-side data encryption, and that allows, we already have data encryption over the network, but currently it's decrypted on the server and then written in plain text to the disk. And so, that's fine if you have clients and servers, working over a WAN or something like that, and you trust both ends. But for, certain types of data, medical data, this will allow you to have the client will encrypt the data, and it'll be written in encrypted form to the OSTs, so you don't actually have to trust the system administrator to store the data, and only the user needs to have the encryption keys for those files. And we're basing this on the kernel fscrypt support. So we're not, trying to develop our own encryption. It's always, people who are smart enough to, develop their own encryption know that they shouldn't develop their own encryption. So we're using this, so it was developed, FSCrypt was developed by Google for ext4, and it's in F2FS is another kernel file system. And so we'll be able to use the same tools and interfaces for that. And it will also be able to utilize the existing, encryption accelerators that are in the CPUs, or, external accelerators like the Intel QAT that's in the kernel if that hardware is available. And another major feature, this is for 2.15 and later, is the metadata writeback cache. This will allow clients to create files and directory trees. Let's say untarring a directory. Let's say it's quite useful for machine learning, where they have a large tarball full of files, or genomics where they have a gene sequence. They untar it at the beginning of their job run, operate on those files, and then delete the tree. And so this will allow very low latency operations to happen directly in the RAM of the client, and the metadata operations will be pushed to the MDS in the background, rather than currently every time you create a file it has to do a round trip. And so it will still be completely coherent with other clients accessing the files. If you have one client that's untarring the files and then other clients trying to access this, it will properly handle flushing the parts of the tree that the other clients are accessing it, without having to flush the entire tree to disk before the other clients can access it. And so we've had a prototype of the writeback cache for a year or more. And so in initial testing, we got, like 10 to 20 times improvement for the single client workload. Untar and make, building a kernel tree was quite good. There's a number of improvements that need to be made before it can go into production. It has to have, memory limits. It has to be integrated with quota and things like that. And so it's, scheduled for, a release a year from now, but it's already started being worked on now. And then once the basic functionality is finished, there's more improvements that can be made, like batching up, creating 100 or 1,000 files at a time and sending that in one RPC to the network, so that we can make that part of it more efficient as well. And I think that's it. Thank you.